Hello, 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 hello. What is that? Uh-huh. Uh, B3, pointer chasing versus column store. B3, row store. So we have root page to internal page to leaf page to row. Each step, pointer, cache miss, branch. So for B3 structure, we have this misprediction and a lot of inefficiencies, unlike with column store. So for column store, we have this chunk like a message pack structure. So we have 1, 2, 3, 4, 5 sequentially, vectorized and fast. Is column store length prefix like message pack? Yes, conceptually. Examples: fixed width, int32, dictionary encoding, RLE, bitmaps. So all avoid variable length scanning. So we have fixed length with message pack, such as we need to provide the length first before the actual bytes or data. It's the same with column store. We have fixed width because we want to avoid the variable length scanning. So a column store use fixed width int32. It could use int32. It could use dictionary encoding, RLE, or bitmaps. And those types of data is all fixed length. Let's continue. What are the main objects? Concrete, not abstract. When I said JSON parser to domain objects to database engine to binary storage, I did not mean JavaScript objects or React objects. Domain objects is equal type structured in-memory representations of database concepts. So you can think about this like a current state, a current in-memory representation of a model to a view. Model meaning the database and the view is the application layer. In PostgreSQL, examples are domain object, heap tuple, what it represents, one row. Domain object, tuple desk, what it represents, schema of a row. Domain object, datum, what it represents, a type value, int, text, UUID, etc. Domain object, plan node, what it represents, query execution plan. Domain object, index tuple, what it represents, index entry. Domain object, relation, what it represents, a table. These are C structs, not JSON. So these are the domain object that you could use with PostgreSQL. So these are its syntax. Heap tuple means you have one row. Relation, it means a table. Index tuple equals index entry. So these are C structs, not JSON. So again, it's not a JavaScript or JSON, it's C struct. It's in-memory representation or representation of that model to application. Example, Supabase PostgreSQL query. Suppose Supabase receive select name from fruits where name like quote AP percentage semicolon. Inside PostgreSQL, first, SQL text is parsed, like with this graph. And then query planner builds execution plan. Then executor produces heap tuple objects. So this heap, you don't see that. It's under hood implementation in C of PostgreSQL. So depending again on how on what is the best or the most efficient way to query, that's the execution plan that your query builder will execute. Then executor produces heap tuple objects. So it will produce this, the heap tuple, and that's where you get the domain object. Each tuple contains type fields. Those fields are later serialized to JSON. So each tuple contains type fields. So it has a field because this is how it mimics the representation from that underhood C struct to a database fields. So those fields are then later serialized to JSON to be able to send to the receiver or to the client that requests it. So from client to JSON parser domain binary storage, and then it will serialize to client again. So domain objects sit between parsing and storage. So Visual Postgre internal. So that's also how you would create an application from scratch. You would start with the domain objects. So that domain objects kind of like mimicking what happening under hood with your storage. Here's the visual. So you have SQL string or the SQL commands, and then a parse tree. It will be parsed by a parse tree at the root, and then query planner will execute plan node structs, and then executor, and then heap tuple, which is row, and then attribute values datum. That heap tuple is a domain object. Second, are domain objects bytes or instructions? They are bytes. So another thing with this, after heap tuple row, that's the only time you get an attribute, not the other way around, such as attribute to row. So the values are later or at the very bottom of the visual or the architecture. So are domain objects bytes or instructions? They are bytes, always bytes, never instructions. So let's be exact. Thing PostgreSQL code, that's where the instruction. CPU treats it as instruction. Kind of like with code in OS. The code, the heap, the code are treated as an instruction, and the heap are the bytes, the data that where that code will be executed, and the stock is also a byte because those are data structure. So JSON data, it's bytes, heap tuple bytes, index page bytes, column chunk bytes. The CPU executes instructions that read or write those bytes. So the CPU then executes those PostgreSQL code that read or write those bytes. The domain object is data, not code. What is a pointer really? Yes, a pointer is a memory address, but not the same as an array index. Compare concept array index, meaning offset inside a known structure. Concept pointer, meaning absolute virtual memory address. So it's a think about this as a memory address where the next the bytes needed from an instruction or code will be retrieved from memory. So imagine it in a CPU pipeline. So the CPU fetch the instruction, and then based on that instructions sequence, if it needs like a bytes or data, it will now point to the memory or some part of a virtual memory that it needs to fetch data from in order to for that instruction to complete. PC is hardware pointer to next instruction. So PC is a hardware, not software, and pointer is a software because it's virtual memory. Example in C, PostgreSQL style, heap tuple, tuple, semicolon, next line tuple, 2, t underscore data, 2 values, argument 0, semicolon. Internally, what that means is tuple to 0x7f10a000, so that's kind of like that's the memory virtual memory address. T underscore data, it's to 0x7, it's equals to 0x7 f10 b120, and values array equals to 0x7 f10 c900. Each arrow equal pointer equal memory address. So that arrow, the two or that equal thing is the pointer. It's what equates to the memory virtual memory address. Pointer versus index. So for index, we have values argument 0 in an array or square bracket, inside an array or square bracket. For pointer, we have values underscore ptr. Index equal arithmetic, pointer equal address. Do pointers run sequentially like program execution? This is a very important distinction. Pointers do not run like code. Like line 1, line 2, line 3. For for data, we have pointer to memory to pointer to memory. So that's the behavior of a pointer. Pointer behavior depends on structure. Sequential data, good for CPU. So that pointer behavior to memory to pointer to memory depends on the structure. So if you have a lot of pointer in a CPU pipeline, it will goes to CPU and get back to virtual memory, which is expensive. But for a sequential data, let's like message byte, we have A8 length and then username A6 Martin. So the pointer moves forward. So pointer plus is equal to length instead of pointer to memory, pointer to memory. So you execute that inside the kind of like near inside the L1 cache of CPU. So pointer heavy structure, but for CPU because object to table to string to heap. So each step unpredictable, cache miss, branch stall. Key inside pointer's job, PC's flows. That's the core difference. Mapping your React code to the full system diagram. So it will be a lot if we finish this. Let's just continue.